In this video, we are going to learn Polyglot persistent principle in microservices. Every microservice has its own data, so the data integrity and data consistency should consider very carefully. The main principle of microservices data management is that each microservice should manage its own data. We can call this principle as a database per service. So that means microservices should not share database with each other. Instead of that, each service should be responsible its own database, which other services can't access directly. It should share data over the application microservices with using REST APIs. The reason for this isolation is block the unnecessary dependencies between microservices. If there is an update on one microservices database schema, this update shouldn't be directly affect to other microservices. Even other microservices shouldn't be aware of these database changes. With isolating each service's databases, we can limit the scope of changes on microservices when any database schema change happened. Also, by this way, we can pick different databases as per microservices. Which database can pick the best option? We can call this Polyglot persistence principle. Of course, this Polyglot persistence principle and separating database comes really heavy challenges. For example, since we have working on distributed systems, managing data is need a strategy. The main challenges are duplicated or partitioned data can make problems of data integrity and data consistency. As you remember that we solved data consistency levels, which are the strict and eventual consistency. So we should decide what is our data consistency level before designing microservices Polyglot databases. In traditional data modeling is using one big databases and every entity table included in one database schema, which is the monolithic applications. By this way, data can't be duplicated and there will not be any data consistency problems due to strict database transaction management. But in microservice architecture, we have to welcome duplicate data and eventual consistency of our entity tables. So, how can we welcome duplication and inconsistent data? First of all, we should accept eventual consistency data in our microservices where it is possible. And we should define our consistency requirement before design the system. And if we need to strong consistency and ACID transactions, we should follow traditional approaches. But except these conditional requirements, we should always try to follow eventual consistency data in microservices. Another way to welcome this feature that is using an event-driven architecture style. With event-driven architecture style, microservices publish an event when any change happened on data model, so the subscriber microservice consume and process events afterwards in eventual consistency model. For example, consumer microservice can subscribe events in order to create a materialized view database that is more suitable for querying data. We will learn these concepts in the upcoming sections. So with separating database in microservices give us ability to scale independently and able to avoid single point of failure of bottleneck databases.